we were either, you can either say introduced or reintroduced to Pythagorean theorem, which was a way to find the missing side length in a right triangle. But the thing is, in order to find that missing side, typically, huh?
Why are you just not saying that?
So with Pythagorean theorem, the thing is, in order to find a missing side, besides not wearing your hoodie, you also had to be given two of the other sides. You can use a squared plus b squared equals c squared if they give you the length of two sides in order to find a missing side. Well, what we're going to take is a little bit of a right turn here into, we're still dealing with right triangles. We're still going to find missing sides. Eventually, we could even find missing angles. But the difference is what they're going to start us with. Instead of starting off with by giving us the lengths of two sides, now we're going to shift to one side and one angle. So when they gave us two sides, in order to find the missing side, we use Pythagorean theorem. Feel free to write this on the side somewhere in your notes. But with one side and one angle, really what we're using is trigonometry. I would say especially starting on Friday, and then when you come back from the break, if you don't have a scientific calculator, it's going to be next to impossible. Okay. What we're doing today is a branch of trigonometry. This is kind of considered trigonometry, but without having to learn any other trigonometric ratios. What did I say we're going to start with today? When they start us with two sides, we use Pythagorean theorem. What are we going to start with today? One side length and one angle measure, right? Now, so the thing is, in order to be a right triangle, what type of angle does every single triangle have to have? 90. Let's accept the fact that every triangle is going to have a 90-degree angle. But then what happens today is if any one of the other two angles, if any one of the other two happens to be either 30 degrees, 60 degrees, or 45 degrees, any of those three, then we can use trigonometry, but without having to round. The reason why I told you that Friday and then when you come back and you need the calculator is because once we get into trig, you might have heard of, has anybody heard of, or at least seen on the calculator, these buttons, sine, cosine, and tangent? Yeah. When you start to use those buttons, there's going to be decimals, and there's going to be rounding. When the angles that they're giving us, that one angle that they're giving us is either 30, 60, or 45, we don't have to round. So that'll be the big difference. You have a quiz on Thursday. They haven't sent me the final copy yet of it, so I'll give you some more information before we get to that quiz on Thursday. But if on any of these types of special right triangles, the big thing is do not round. The quiz might tell you to round for Pythagorean theorem problems. I don't know because I haven't seen it, but you should never have to round when we're dealing with special right triangles. So there are two special right triangles. The reason they're special is because of those angle measures that they have. The first one is known as a 45, 45, 90, or to see who's paying attention and who's writing down notes, because you're going to get asked this later. Another word for this is an isosceles right. An isosceles right triangle is also known as a 45, 45, 90. These are one of those weird things where even if you're not really too strong with geometry and you're not a big fan of it, but later on, it's just one of those things that sticks with you. Somebody next year asks you, oh yeah, remember when you went over 45, 45, 90s? You're like, oh yeah, that's true, I remember that. How many sides does a triangle have? So if I know that one of my angles is 45 degrees and they give me one of the legs, I know that because this is isosceles, the other leg has to be the same. They're equal. Come through it. And then if they give me a leg and they want to find the hypotenuse, all I have to, instead of having to use Pythagorean theorem, what a special right triangle is that we can either multiply or divide by a factor to be able to get the missing side. It's like a conversion, like the same thing like turning inches to feet or turning gallons to pints, and there's going to be a number that we can either multiply or divide by to get the measurement that we want. So if they, on the 45, 45, 90, if they give me a leg and they want the hypotenuse, I'm going to multiply times square root of 2. I'm not going to get the decimal. If anything, I'm going to leave it as some number times square root of 2. I might have to simplify a radical, which we know how to do with the factor tree. But you're going to multiply by square root of 2. So therefore, the opposite, if that one side that they start us with is the hypotenuse and they want the leg, what would be the opposite of multiplying by square root of 2? Divide by square root of 2. That's the only thing you really have to know how to do on a 45, 45, 90. So where the mistakes happen is now there's only one other special right triangle. And once we introduce that one, people confuse those conversion factors. 45, 45, 90 is real simple. Because once you know one leg, you already know the other leg. So the only thing left to find is the hypotenuse. If they give you the hypotenuse, once you find one leg, then you know the other leg. There's only two different measurements on a 45, 45, 90. Depends on what they start you with. His question was, how do you find a leg? Well, if they give you the other leg, how would you find the leg that you want? They're the same. If they give you the hypotenuse and you want to find the leg, divide by square root of 2, which we'll go over in the examples. Natalie, question? Answered it? Okay, now the one that gets a little bit more tricky, because all three side lengths are different, it's a 30, 60, 90. I said we already accepted that every right triangle has to have a 90-degree angle. What do all the angles inside of any triangle add up to? 180, right? So that's why if on the one before, if we know we have a 90 and one angle is 45, the other one has to be 45 because that adds up to 180. On a 30, 60, 90 special right triangle, which is the only other one, we know we have a 90. If one of them is 60, the other one has to be 30 and vice versa. If one of the angles is 30, the other one has to be 60. But this creates three different side lengths. So I don't know what other teachers call them. I've never really seen this in a book, but just to keep it simple, we know that the sides that meet at 90 degrees are the legs. For the purposes of discussion, dialogue, we're going to call one the short leg and one the long leg. The short leg is always across from the 30. My advice to you, and look, I'm going to try to make this as easy for you as possible, but sometimes there's a way of oversimplifying things. The only conversions that I'm going to provide you involve the short leg. If they give that one to you at the beginning, if that's the one side that they're giving you, great. It just makes your life easier. But if they don't give you that side first, that should be the side you find first. I'm only going to provide you conversions that involve the short leg. The short leg is always across from the 30. The long leg is across from the 60, and then in any type of right triangle, the hypotenuse is always across from the 90. See if you can figure out these abbreviations. What do you think SL stands for? Short leg. So if you start with short leg and you need long leg, what do? You multiply by square root of 3. If they give you short leg and they want hypotenuse, this will be one of the easier ones. It's just times 2, not times square root of 2, it's just times 2. If they give you long leg, okay, see, the only thing I'm not going to give you is I could, but it's more memorization and it's not necessary. So I'm not going to give you a conversion from long leg straight to hypotenuse. So let's say they gave you long leg and they wanted hypotenuse. I will provide you with long leg to short leg, which is dividing by square root of 3. And then once you have short leg, Now you can just use the one up here to get the hypotenuse if you want. That's just the opposite of what you saw here. Instead of times square root of 3, it's divided by square root of 3. If they give you hypotenuse and they want short leg, then just divide by 2. Another thing I will do to try to make life a little bit easier on you, the only ones that should cause you or could cause you a little bit of trouble are these. The ones where you are dividing by a radical, when you divide by a square root. Now, if you have a fancy calculator like Wyatt did the other day, yeah, the calculator does it for you, but that kind of defeats the purpose. So I will help you out by showing you what that division would look like if it were to be rewritten as multiplication. Anytime you get a number and divide it by square root of 2, it is the exact same thing as multiplying by square root of 2 over a regular 2. You'll see in the examples how that could help you. It depends on the number they give you. You can use any one of these two. Same thing. Anytime you divide a number by square root of 3, it's the same thing as multiplying by square root of 3 over a regular 3. I've tried to provide you with enough examples where you'll see all of these put into play. But just try to learn these conversions. Any questions so far? Okay, you got something that's growing out of here. No, on the other one. There it is. How'd that get there? Okay, let's look at this first one, the one that says number 12 next to it. They want us to find x and y. What do you see right next to the x? A degree symbol, right? That means that x is an angle measure. So if we look at, like really, we can ignore this whole triangle over here. We can just ignore that. Alright, so even though what they're giving us is a square, we can always, the only reason we even need that is to know that because one side is 9.6 and all the sides are the same, that means that this side is 9.6. And because what type of triangle, besides being right, what type of triangle is it that x is inside of? Good. So, and what do we call when isosceles right? So this one x is 45 because x is the degree. X is the angle. Now y, on the other hand, was not an angle measure. Y was a side measure. Specifically, it's this side that I'm just highlighting right now. What side is that in a 45, 45, 90? It is the hypotenuse. Now, the difference between special right triangles and the ones we had last week is that instead of giving us two sides, because they're giving us an angle measure, they only have to give us one side. They are giving us one side. What side are they giving us in that 45, 45, 90? A leg. So how do we turn a leg into a hypotenuse? Now multiply by 2. Multiply by square root of 2. So take the leg that they're giving us, which is 9.6, and multiply it times the square root of 2. Now this isn't my favorite example because the whole purpose of special right triangles versus trigonometry, like the reason why we don't just jump to Friday's lesson and we actually have these special right triangles is to avoid rounding. And what do you guys associate rounding with? No, there's more rounding than just division. What do you associate rounding with? When you round, what are you rounding? With decimals, right? So you're like, wait, but Mr. Romero, we're not supposed to get a decimal. Yeah, typically these types of problems don't really mix well with decimals, but if anything, this decimal that you see here, it's not irrational. It doesn't go on forever. It doesn't need to be rounded. So you ready all at once? Wait, that's it. We're done? Yes, that's it. We're done. For real, for real. Believe that. Solve for what? I've already solved. Is there any operation that can be done here without rounding? No. You have a square root, but if you take the square root of 2, that's going to give you a decimal that goes on forever. We'd have to round. And then, of course, once that goes on forever, if you were to multiply it with 9.6, that would also still go on forever without repeating or anything. So we are done. Any questions on the first one? Let's go to, yes?
So, because
Yeah, you leave it as square root of 2. Yeah, and anything, look, the only time that you're going to do something with a square root is if the number that they're providing you already has a square root in it. Like, let's say they would have told you that instead of 9.6, let's say that this would have been like square root of 18. Well, since that's already in a square root, I would still multiply it by square root of 2, but since they're both in a square root, now the numbers could be multiplied together. What's 18 times 2? 36. That number would still be in the square root, and gee, when you look at that, what's the square root of 36? 6. So, like, something could be done, but no rounding. I didn't have to round it all, I just simplified. What I have here cannot be simplified, like we're done. If you don't understand the concept of rounding and not rounding and when to round and blah, 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 let's look at this one. Maybe this next one's a better example. But understand what type of a special right triangle is this. There's only 2 special right triangles. So even if you were to guess, if you were, okay, see that was a guess. It was the wrong guess, but at least it was a guess. Very good, Jair. Good. Huh? Okay, well, yeah, I normally call it a 30, 60, 90, but fine. That's more of a. This is a 30, 60, 90. So a 30, 60, 90 also has legs and a hypotenuse, but the difference is because it's not isosceles, Jair, the legs are a different size. So what you have to identify is, well, which side are they giving us? Did you give me back the ruler? Which side are they giving you? They are giving you the hypotenuse. How do you know it's the hypotenuse? Because it's across from the 90. Okay? So what I recommended to you, not out flatly told you, is which side should we always find first if it's not already given to you? The short leg. Let's always go with the short leg first. Between X and Y, which one is the short leg? It is X. If we're given the hypotenuse, how do we turn a hypotenuse into a short leg?
Divide by 2. Multiply.
Divide by 2. Thank you. Hypotenuse to a short leg. So take what they give you, which is 18 divided by 2. Now that I have the short leg, the world is mine. How do I go and turn a short leg? I'm not going to go from hypotenuse to long leg. How do I go from short leg to long leg? Good. Multiply by square root of 3. So y equals what the short leg was, which is 9, times the square root of 3. Done. Anything else that we could do would involve rounding. We don't want to round, so we're done. Easy peasy, lemon squeezy. Believe that. Facts. Facts. I'm keeping it 100. I'm not ignoring it. What the 60 tells me is that it was a type of triangle. I wouldn't have been able to do anything else if I would have not used the 60 to recognize that this was a 30, 60, 90 special right triangle. But now after that, they're not asking me about any angle measures. They're just asking me about sides. Specifically, they're asking me about the short leg, and then they're asking me about the long leg. So I just use those conversions, which hopefully you will memorize soon. Yes. Bazit, you okay? It's a good thing you didn't wrestle against the desk. That would have beat you every time. That desk is dominant, man. The length of an altitude of an equilateral triangle is 12 feet. Find the length of a side of the triangle. Okay, so what does equilateral mean? It does mean same sides. That's correct. But it also means same angles. And if I know that all the angles add up to 180, what are the angle measures in an equilateral triangle? Very good, 60. 60, and especially that now we're sort of coming off a lesson on constructions. Plus, we had already been introduced to the special segments earlier this year. If I were to draw any one single altitude, I know that altitude would go from one of the angles to the opposite side and meet it at 90 degrees. So now what I have is, let's just call you, I always like it when they define the variable for you, but they haven't, so let's decide to call, what are we're looking for? We're looking for the length of one of the sides of the big triangle. By drawing that altitude, what have we now created? Well, we have created a 30, 60, 90 because we have the 90 from the altitude, we have the 60 from the equilateral, which means that the one that's left over has to be 30 because that's what adds up to 180. And the 12 they've given us for the altitude, which side is that acting as in the 30, 60, 90?
Long leg.
Very good, Josh. Long leg. Long leg, and it's across from the 60. The one at the top is the 30 now because we cut it in half of the altitude. So it's just a matter of, okay, have we identified the special right triangle? Yes, we know it's a 30, 60, 90. Have we identified the side that they're giving us? Yes, we said it was a long leg. Now, what's the side that we're looking for? With hypotenuse. I did not give you a conversion from directly from long leg to hypotenuse. So we're going to have to take a detour through the short leg. Okay, so let's find first short leg. Let's call the short leg Y. How do you turn a long leg into a short leg? Divide by square root of 3. Well, here Papa Romero took care of you because division with radicals might challenge some of you. You have to do something known as rationalizing the denominator, which you should have learned in Algebra 1, but in my experience, I found that a lot of kids either don't remember or claim they've never learned it. If the number on top would have a radical, like a square root, then yeah, sure, go ahead and divide it this way. But I took care of you so that when you don't have a square root on top, what did I tell you that dividing by the square root of 3 was the same as? What did I tell you that dividing by square root of 3 was the same as? Like I literally wrote it on the board, which means that you wrote it on the paper. Multiplying by square root of 3, but then dividing by 3. I wrote it for you on the first page. Dividing by a square root of 2, if you ever needed to, is the same as multiplying by square root of 2, and then dividing by a regular 2. And dividing by a square root of 3 is the same as multiplying by a square root of 3 divided by a regular 3. So I came back and I prefer to use that instead, because if I multiply by square root of 3 and then divide by 3, now I can actually divide that 12 by something. What can I divide the 12 by? What's 12 divided by 3? 4, but I have to keep the square root of 3 next to it. So that's my short leg. Now that I have my short leg, how do I turn a short leg into a hypotenuse? Multiply by 2. So the x, which is what I wanted, is going to be the short leg, which was 4 square root of 3, but now times a regular 2. Which number do I multiply times the 2, the 4 or the 3? Just the 4. 4 times 2 is 8. Josh, buddy. Any questions here? Ooh. I haven't looked at the final copy of the quiz yet, so I don't know if these are gonna be on the quiz, but I'm almost certain that these showed up on the written assignment. The digital one, I don't think so. I don't think this would be on the digital one, but this would be. I'm almost certain I was able to put these on the written assignment. Where now we have compound figures that triangles that share a common side. How many triangles do you see? Two. The one on the left is a 30, 60, 90. The one on the right is, okay, keep that in mind. So let's see. In order to be able, they want us to find X, Y, and Z. X, Y, and Z are all side lengths. So they have to give us an angle, which they have, and now we wouldn't have been able to identify those triangles. But they also have to give us a side. What's the only side they're giving us? And that 8 is only part of the 30, 60, 90. So we're going to have to start off with the 30, 60, 90. On a 30, 60, 90, what side are they giving us? What side is that 8 on the 30, 60, 90? It's a hypotenuse. So when it's not given to us, which one should we find first? Short leg. Has that short leg been defined? And have they given it a... Well, that's what define means, that they give it like a name. So it's X. So I want to find X first. How do I turn a hypotenuse into a short leg? Divided by 2. So 8 divided by 2, which is, as Jair says, foe. Now that I have the short leg, how do I turn a short leg into a long leg, which also happens to be a Y here? No, not multiply by 2. Multiply by square root of 3. So watch this. 4 square root of 3. Yay, finished. But that Y right now is being two-faced. Because not only is it acting as the long leg of the 30, 60, 90, what is it also acting as? The hypotenuse of the 45, 45, 90. And what is Z in that 45, 45, 90? It's a leg. So how do we turn a hypotenuse into a leg on a 45, 45, 90? You would divide by square root of 2, but look at the number that we have to work with. Yes, we have a square root there, but man, 3 can't be divided by 2. So I'm gonna prefer to use the alternate one, the one that I gave you to help baby you guys. So it's gonna be start off with that 4 square root of 3, but instead of dividing by square root of 2, what did I tell you to do? Multiply by square root of 2 over 2. That's the same thing as dividing by square root of 2. So now I can actually divide the 4 by 2. What's 4 divided by 2? So this becomes a 2, this becomes a 1. They cancel out. And because the 3 and the 2 are both inside a square root, those can be multiplied. 3 times 2 is, let's get 2 square root of 6. If you're not blessed with White's calculator, you have to know how to do this by hand. X, Y, Theo wouldn't want to be a... Yeah. I did. I took what I had, the short leg was 4, and I multiplied by square root of 3. That's if you have to divide. If you ever have to divide by square root of 3, dividing by square root of 3 is the same as multiplying by square root of 3 over 3. But we didn't have to divide by square root of 3 because dividing by square root of 3 is equal from long leg to short. We weren't going from long to short. We were going from short to long. So it's just times square root of 3. Just to figuring out what they're giving you and what we need to find. Am I going too fast? Shaughnessy, are you all cheered out? Were you there this weekend? I didn't see you this weekend. No. Hmm? What is the perimeter of the square? What do we know about squares? All sides are congruent. So when I draw a diagonal, such as the one that you see now, what type of triangles? Those are going to be 45, 45, 90s because it's isosceles. Those are isosceles, right? And if they are 45, in order to find perimeter, I have to add up the sides. If all the sides are the same, I only need to find one side. That side on any of those sides on a square is the same as, and let's say let's call this X. I like it when they call it something for you first, but whatever. Once I find one side, I can just multiply times 4. That side is acting as a leg. How do I go from a hypotenuse to a leg on a 45, 45, 90? Divide by square root of 2, Natalie. You could also multiply times square root of 2 and then divide by 2. That's the same thing. But because I already have a square root of 2 there, it would actually be in my interest, in my best interest, to just divide by square root of 2, because then those would cancel out. Either one works, and you're going to get the same thing either way. But it just makes more sense to divide in this case instead of multiply by square root of 2 over 2. So now one side ends up being 18. So how do I then find the perimeter? You could either do 18 plus 18 plus 18 plus 18, or as he suggested, 18 times 4, which is 72. Well, it says centimeters here, but it's probably wherever I got this from. It probably said in the instructions a small measurements. It doesn't say it there though. Mohammed, you are? I need to get your vision checked. You might need to get your vision checked then, man. That's not good. You want to sit closer? You sure? Hey, look, it's a baseball field. Mm-hmm. Not just of any baseball field, it's the historic Comiskey Park in Chicago. So this diagram shows the dimensions of Comiskey Park. BD is a segment that goes from home plate to dead center field, from B to D. And AE is a segment that goes from the left field foul pole to the right field foul pole. If the center fielder is standing at C, how far is he from home plate? So it looks like here they have defined the variable for us. They decided to call this X. What segment are we looking for specifically? Oh, it's gonna end up being a leg, yes, but like, what's the name of the segment? Other than like the distance is gonna be X, but what's the name of the? If the right fielder is standing at C and we want to know how far he is from home plate, what point did they call home plate? Huh? B, yeah. So if they wouldn't have put this X here, you would have seen me just put in like BC equals. But since they didn't put an X in, let's call it X equals. And how many triangles do you see on the page? And all 4 of those happen to be 45, 45, 90. I'm gonna focus on just the one here on the left, but doesn't really make a difference. And they tell us that from home plate to the left field foul pole is 347 feet. What is that 347 feet acting as in the right and the 40? The hypotenuse. How do you go from a hypotenuse to a leg? It's supposed to be divided by square root of 2, but Natalie, since the measurement that they're giving me doesn't already have a square root of 2, since it doesn't already have a square root of 2, I'm gonna opt to use the times square root of 2 and over 2. Because you're not supposed to leave a radical in the denominator. In order to be in simplest form, like, I'm just trying to tell you, this is the same thing as saying 347 divided by square root of 2. It's the same thing. But I just can't leave it like that because that's that's not in simplest form. You can't leave a square root in the bottom of a fraction. So in many instances, the advantage I gain here is that if these two numbers can be divided, I would actually be able to divide them. But can 347 be divided by 2? No. The whole purpose of special right triangle is not to round, so I would just leave it like this. But it is very likely, though, because this is not just a typical problem, this is like a word problem, they would probably ask you to round. And if they did, you would just put that into the calculator. Can somebody put that into the calculator just to give us an idea more or less? Should end up being maybe 170, 160 maybe.
245.36.
245?
Yeah, 245.36. Oh, yeah.
Okay. Huh?
If you would around.
Oh, man, it's at 116.
Yep, he's right. 245.3. So he's more or less 245 feet from home plate. Any questions there? Ooh. So every triangle in this figure is a 30, 60, 90. So find x. Okay. What is x? X is part of only one of those triangles. What side is x acting as? It's the long leg. Because if this is the 30, that means this is the 60, so the x is across from the 60. It's the long leg. Now the 4 that they're giving me is part of. I know. Okay, I'm sorry. I phrased it poorly. What side is it? And it's the hypotenuse of that one. So in order to find x, I would start with a 4, but I have to go from a hypotenuse to a long leg, then do it again, do it again, then do it. I have to do it 4 times. Okay. So let's see what that would involve. How do I go from a hypotenuse to a short leg? Because I don't want to go straight to long leg. Divide by 2. What's 4 divided by 2? 2. So then what I would do if I were you, okay, let's just do it in several steps then. All right, so now let's start off with the 2. How do you go from short leg to long leg? Times square root of 3, right? But then, now that I'm on this long leg, I gotta go back to the short leg. How do I go from long leg to short leg? No.
Multiply by the square root.
Actually, no, I'm sorry. I take that back. I said it wrong. Yeah, because no, this is the long leg, but it's the hypotenuse of the next triangle. So I'm sorry. How do we go from hypotenuse? Because this side right here is the long leg of the big one, but it's the hypotenuse of the next one. So how do I go from hypotenuse to short leg again? Divide by 2. So I'm going to put this divided by 2 here. I'm just going to try to do it all in one, and hopefully I don't confuse you. Okay, so now we're right here, and this is where we've left off. Let's go to long leg again. How do I go from short leg to long leg? So let's multiply by another square root of 3. Okay, but then we're going from hypotenuse back to short leg. How do we do that again? So we can put another 2 here, but we gotta multiply them on the bottom. Just put another 2 on the bottom. Okay, then we go now to the long leg there. How do we do that again? Times another square root of 3, but then again, we gotta go to the short leg, so we divide by an extra 2 on the bottom. And then finally the last thing is 1 extra square root of 3. Did I confuse you by doing everything at one time? I was just trying to avoid decimals.
No.
So what we end up with is I can get one of these 2's to cancel, but I can't do anything about the other 2's. On the bottom, what's 2 times 2?
12.
Okay, very good. Right here, minus 12. On the top, everything is underneath the square root, right?
Oh, square root of 3, right?
No, it would not be 4 square root of 3. That would be the case if you were adding them. But if you're multiplying them, you can actually multiply the numbers on the inside. So what is 3 times 3 times 3 times 3?
18.
No.
27.
12.
84. Oh, 81.
Oh,
Can I take the square root of 81?
Yes.
What is it?
9.
And now we're done. He added. He likes to add. Okay, the sum of the square. Ooh, okay. The sum of the squares of the measures of the sides of a square is 256. Find the measure of the diagonal of the square. Okay. So they want us to find the measure of this diagonal. Let's call this x because that's what we're looking for.
Wait, what?
Yeah, we're about to turn words into math. This will be the last one today. Let's call the length of a side y, right? And they tell us the sum of the squares of the measures of the sides is 256. So if this were to be y, that means that if I were to square y, and then how many y's are there going all the way around? Because they say the sum of the squares of the measures of all the sides. The sum. If I were to add up all those y squares, that would give me 256. So divide by 4. Y squared is 64. What's the square root of 64? 8. So I know now that y is 8. What type of a special right triangle is it when you get a square and you draw a diagonal? Also known as 45, 45, 90. How do you turn a leg into a hypotenuse on a 45, 45, 90? Not by square root of 3. Times the square root of 2. So what we're looking for here is 8 square root of 2. There's the one that didn't make all the way down. It has a